This is a video on how to come up with the equation of an ellipse or a hyperbola given certain information. And the information that could be given for an ellipse is either, the foci, the major vertices along the major axis. They could also give you the length of the major axis and the length of the minor axis or the minor axis vertices. Either one is perfectly good for finding a lot of information. Most of these numbers you would have to cut in half. For instance, A is usually related to half of the major axis, and B is related to half of the minor axis. One thing to notice to make sure we're talking about an ellipse is the foci are always on the inside of the vertices. So when you have these two vertices and the foci are inside of it, then we're talking about an ellipse. Over here, these are the foci, but you'll notice that they're on the outside of the vertices, or outside on the line segment that connects the vertices. So that's what forces this to be a hyperbola. One thing you won't be given is the length of B, or the minor axis, if you want to think of it that way, with a hyperbola, because all they have is the vertices and the foci. So B is always going to be one of the unknowns. All right, so the goal here is if the focuses are on the inside, we're talking about ellipse. If the focuses are on the outside or beyond the vertices, we're talking about a hyperbola. So at least gives us a general formula to work with. And then most of the other information will come from the relationship between A, B, and C, where in an ellipse case, oops, I'm using small letters here, C squared is equal to A squared minus B squared. And with the hyperbola, it's the Pythagorean theorem set up, C squared equals A squared plus B squared. All right, so let's look at a couple of examples. Here's one of them, and I always do a picture so I can be guaranteed in my head that I'm talking about the right conic section. So here I have the foci of a conic section are located at -3, 4 and -3, 0, and vertices are located at -3, 6 and -3, -2. And I want to find the equation of this conic. All right, so I'm just going to plot these, and I'll color code them. I'll do vertices as green, and I'll do the, I'll do the vertices as green, and that way I don't have to change the color here. And I will do the foci in blue. All right, so let's plot these. We'll start with the vertices, -3, 6. -3, 6 up here. So I'm just gonna label this V to remind myself that that's a vertex. And then -3, -2. So -3, -2 is someplace down here. That's another vertex. All right, and then the foci, I'll color them in blue, are going to be at -3, 4, so -3, 4. And the other foci is going to be at -3, 0. All right, so these are the foci. So when we're talking about the vertices and foci relationship, I'll go back to this picture here. If the foci are in the inside, then we're talking about an ellipse along the line segment where the vertices are. If the foci are on the inside, we're talking about ellipse. And on that line segment, if the foci are outside of the vertices, then it's a hyperbola. So this one, the foci is on the inside, so we're talking about an ellipse. All right, so to deal with A, B, and C, we need to know where the center of this ellipse is going to be. And it's going to be the midpoint of either the vertices or the foci. So since the foci are 4 to 0, if we're talking about just the y-axis here, then the center has to be right here, which would be -3, +2. So center at -3, +2. You can also use the midpoint formula between the foci if it's going to be off-centered, off-countable. So that would work also. All right, so that becomes part of our equation. The other thing we can determine really quickly from the picture is this distance has to be C, because it's the distance from the center to the foci. And this distance from the center to the vertice is A. So then we can come up with the B part of this equation by using our little formula for ellipses, a squared minus b squared, and plug in what we know. Well, C is, well, this distance is just 2. So this would be 2 squared or 4. A is 1, 2, 3, 4, so that would be 16 minus b squared. All right, to solve this really quickly, I'm just going to switch the b squared and the 4. So this becomes b squared is equal to 16 minus 4, or b squared is equal to 12, or b is equal to the square root of 12, which is 2 squareds of 3, plus or minus. This number is actually going to become more important for us. The 2 squareds of 3 is only if we want to graph the picture when we're done. All right, so b squared is 12. A squared up here was 16. So the equation is going to be x minus h all squared plus y minus k all squared all divided by b squared is equal to 1. So all I have to do is figure out where does the a go. Well, the a has to go with the vertical variable because that's where most of the stuff is happening. So the a is going to have to go here. So this would be 16. Therefore, the b is going to have to go here, which is 12. And then we just have to use the center to come up with the right coordinates here. So it's x minus h. H is negative 3, so that would be x plus 3. K is 2, so y minus k is going to be y minus 2. And this is the equation of the ellipse given the information above here. All right, let's try this one. The foci of a conic section are located at these two coordinates. The vertices are located at these two coordinates. And then we can plot them in our graph and see what this thing looks like. Well, hopefully I can plot it in my graph. All right, so let's see here. Conic section, foci. I think I colored them green last time. No, I colored them blue. All right, so the foci again in blue, the vertices again in green. I'll start with the vertices. Negative 1, 2, negative 1, 2, and 5, 2, so 5, 2. And these would be the vertices. All right, foci, negative 2, 2, negative 2, 2. There's a foci. And 6, 2, which is over here, 6, 2. And there's my other foci. Now the foci are outside of the vertices, so this thing is definitely a hyperbola. And also the same thing's going to happen. We're going to be looking for the midpoint of that line segment. I'll use the v's this time. And just by counting, 1, 2, 3, 4, 5, 6, it's going to be 3 away, half of it. So here's the center. So the center is happening at 2, 2. Get that in there. So we're talking about a hyperbola with a center of 2, 2. The distance from the center to the vertice, in this case, is 3. And the distance, equation-wise, is going to be a. So here we have a is equal to 3 from the center to the vertice. Now the center to the focus, we're talking about this distance here. That's going to be c, because c is always related to the foci. And that distance is 4. So that gives us our A and it gives us our C. We have our center. So all we need is the B out of this. So I'm going to set this up as C squared equals, if it's a hyperbola, it's A squared plus B squared. C in this case is 4 squared. A in this case is 3 squared, so we're looking for B squared. So this becomes 16 minus 9 is equal to B squared. Oops, B squared. 16 minus 9 is 7. And therefore, B is equal to plus or minus the square root of 7. But the important one that we want is B squared is equal to 7. So when we set up a hyperbola, the important part is not the A being bigger, it's where the foci and vertices are lying. So in this case, we're going this direction with our hyperbola and this direction. So that means since we're opening up left and right, the first variable has to be x, and the second variable has to be y. So we're going to get x minus h, y minus k, in between them is minus, and it's equal to 1. Alright, so it really doesn't matter, but x has to go with the a in this case, so this would be 9. Remember, a squared is 9. With the y, it goes the b, and the b squared we found out earlier was 7, so that gives us 7. And then the center was 2, 2, so this becomes kind of easy. X minus 2, y minus 2, don't forget the squares. And this becomes a hyperbola according to the information above.